started. So, who here has seen the second tutorial? Has watched that on the, or been there or watched it? If not, you should be able to catch up pretty easily. So I'm just going to start with reviewing just what the render and update was, because it's been a while. So, pretty much, computers don't run all at the same speed. And if we just had one function like that while loop that just ran the game as however fast as that function could run, you're going to have different things happen on different computers. For example, when I run what we have right now on this computer, which is a decent computer, the oval moves across the screen pretty smoothly. If you run it on Vlad's little computer there, that's the school's computer, it's really laggy and it glitches off the screen a little bit and it's weird. But yeah, so what we're going to do is we're just going to handle having different speeds on different computers. And this is going to be much more important when we get more into game logic and actually having players move around. Let's say we have a player and we want the player to move to this position and we have a speed. Well, every frame you're going to want to increase that speed by a certain amount, so the player, or increase the player by the speed so that it moves. But if the computer's running at a different speed than another one, then the player will move faster on one computer than it will on the other. So it's going to be a problem, not even just now, but in the later stages. So what we're going to do to fix this is we're going to put another element into the equation, and that is time. So, yeah. Render is a method we're going to use that will just run as fast as the computer will run it. So this is actually going to render everything we have to the screen, and we want that to run as fast as the computer can handle running it. The update method will run at a specific rate. And the render method will render everything to the screen. The update method will update all the movement and change any variables. Update will be the same on every computer. We want to make sure that it runs exactly the same on every computer. So does that all make sense? That's review from last time. If you have any questions at all, just put your hand up. So what I was saying earlier. What? If the computer, yeah, that's actually another thing as well that we're gonna make update run. Like it'd be hard for a computer to be that slow. Like it would have to be a really bad computer. But if that does happen, then yeah, update will run slower than. That's actually that still happens in AAA studio games today. I think on Ethan's old laptop, he used to play Minecraft with me, and on occasions, his laptop would just get so overheated that it would just all mess up, and the actual game would run faster or slower depending on what happened, because the game clock kind of got all messed up. So yeah, that's something that's just gonna happen. Let's go back to our code here. And let's start implementing some of this stuff, because we never actually implemented anything last time. We still have this really bad while loop with everything in it. It's like, why can't I see that? So, what we're going to do for now is we're probably still going to use a lot of this code, but we're just going to go ahead and comment all this out. If you're in Sublime Text, you can select the whole thing and do Control/, and it'll slash the whole thing. We're going to write a new loop here. Well, a little bit more sophisticated than just a loop, actually. So the only real thing that we have to know for this, as far as Java goes, is that in order to get the time in nanoseconds, you use system.nanotime, and we can only get the time in nanoseconds, so that's really the only Java thing we have to know here. System.nanotime is how you get time in Java. And what I'm going to do is I'm going to create a variable called last time, which is equal to this. And every single time the method runs, it's going to check the last time, and we're going to reset the last time at the end. So another thing we need to do is actually this cannot be an integer. There's another primitive type that we haven't actually learned in class, and you all remember what primitive types are. It's something that is already in Java, and yeah. Anyway, we want to use a primitive type called long, and it's actually really simple to understand. All it is a longer integer. It's an integer that can store more space. It's really all it is. And I think the maximum, if you care at all, the maximum size that's going to be is 2 to the power of 63. So it's very useful when you're dealing with bigger numbers, but If you're not, I would still recommend using integer because long can take up quite a lot of space. So another thing we need to do is we don't really want to deal in nanoseconds here because then it'd be a little bit more difficult to deal with these numbers. So what I'm going to do is, sorry, not fine. I'm just going to say, what? Because right now this system.nanotime is going to be in nanoseconds. So what I'm going to do is I'm going to create a double here called nanosecond conversion. It's a double because this is going to be it's not going to be an integer, it's going to have decimal places. And what I want to do is I'm actually just going to go to Google, and I'm going to go nanoseconds to seconds. I'm going to figure out what I want my frames to second to, I'm going to figure out what I want my frames per second to be. And so pretty much I want to figure out how many updates I want per second. So if I want, let's say, 60 updates per second, I'm going to go ahead and do 60 seconds to nanoseconds. And that is 6 e to the 10th. Okay, I should do this instead. Let's do 1 second to nanoseconds. And when you do that, it's how many zeros? Well, it's 9 zeros, isn't it? Yeah, okay. So, yeah, we want to go back to our code now. Actually, this is easier. Yeah, just type in 1 second and get nanoseconds, which is 9 zeros. What we're going to do, this might seem a little stupid, but we're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, whatever number that is, divided by whatever we want our frames per second to be. So I want 60 frames per second, let's say. Okay, we'll see what you can do with what we're giving you, and you can always watch the recordings and catch up with that. Okay, so does that make sense? The reason we care about this at all is because we need to convert our time from nanoseconds to seconds. So now I'm actually going to create a while loop again because we still want a loop. So we're just going to do while, and then we'll put in true for now, but I am going to put something else in there for a soon, so we can have a little bit more control over this. And what we're going to do is every time we pass through this while loop, we want to have a variable called now, which again has to be a long because it's going to be nanotime. Again. And the reason we want that is because we want to see how now compares to the last time this ran. And at the end of what we do, we're going to want to set last time to now. And then all of our code that's going to be dealing with the time is going to be within this. Does that all make sense? So now we need to figure out how much this has changed in seconds. So what we want to do is I'm just going to call this variable, I'll call it delta seconds. Change in seconds. You can call it whatever you want. Change in seconds if that's easier for you to understand. And that's going to be, we want to actually declare this up here. And I'll tell you why in a second. So go ahead and declare whatever it is up here and call it a double. And the reason we want to declare it up there is because every single time this while loop runs, it's not going to be 60 seconds every single time. Or, sorry, it's not going to be whatever our frame rate is every single time. So we want to actually increase delta, or change in seconds, whatever you're calling it, by our time difference. So that's going to be now minus last time. And we're going to divide that by the nanosecond conversion. And if it's hard for you to wrap your head around all this math, honestly, don't worry about it because this isn't really the reason we're doing game programming. This is just kind of getting us started, getting us kind of a framework. so we can get really into the actual programming of games. So, yeah. It sucks that we have to go through this whole process to start out, but...
It won't let me take the text and paste it into the game.
Okay. Just save it. You can just save it as .java.
Save as.
So, we can do two things here. And actually, this is what I meant to say earlier, but I didn't. We could get rid of the 60 up here. And if we did that, our change in seconds would be, we'd put another while loop here, and we say while delta seconds, or change in seconds, whatever you have, I have it, change in seconds, I guess, is greater than or equal to 60. And if that's easier for you to understand, go ahead and do that, because it really doesn't make any difference. So what we're doing is, we've converted our time to seconds, so change in seconds is going to be how much our time has changed in seconds. And now we're going to check while change in seconds is greater than or equal to 60. And if you're wondering why I'm not just saying while is equal to 60, it's because if we're somehow skipping a frame or something weird is happening, just to make sure that we don't just like never do anything. In case, you know, for some reason change in seconds goes above 60. And also, if you want to make sure that change in seconds works, you could print it. I might do that right now. You don't have to do this if you want, but... Can I add an extra 0 there? No, actually, that's the print line lagging. That's not the seconds lagging. Sorry, yeah, don't worry about that. it is changing in seconds, trust me. I was like, that didn't seem like it was seconds, but it was just the print line lagging. So, within this while loop, this is where we want to call our update method. Because remember, the update method is the method that runs at a specific rate on every computer. So, let's go ahead and create just a blank update method, and we'll put stuff in it later. Oops. And we're going to want to call that inside the change in seconds. What we also want to do is set change in seconds back to 0, so that we can go through again and go back to this while loop when we've reached 60. When we've reached that point again. When changing seconds is 60, that's what I need to say. And if you're wondering what we're going to call our render method, it's actually pretty simple. We're just going to call it right there, outside of this while loop, but inside this while loop. So it's going to run as often as render can be called. And there's no like check to render as far as time goes or anything. So create a blank render method as well. Any questions so far? That doesn't have to be above, it can be anywhere. Yeah, it really doesn't matter at all. So, what we're doing in the render method is we're rendering everything to the screen, and in the update method, we're updating position. So right now, what we had before, and what we had commented down here, is we were kind of just like brute forcing the whole change position thing. What we're going to do instead is we're going to render position of the oval with the render method. I'm going to change the position of the oval with the update method. I don't think so. Actually, we need a lot more than those lines of code. I just wasn't really paying attention. We want everything that has to do with graphics. So fact, let's just copy this whole thing and I'll take out what we don't need. So copy everything you had inside the commented while loop into the render method. And then we'll uncomment it. And we're going to have to, for this first line where it just says buffer strategy equals canvas.get, we're actually going to have to put buffer strategy class name before that because we don't have that up here. So we had it down here, but we're not up here. So, and then once you do that, I actually think we're good. Just make sure your render method looks like what we have up there. And we also need to create a field. And if who here knows what a field is? What's a field?
If they,
It's a variable, but where's the placement of the variable?
inside the path itself,
Yep, so a field is something that's going to be in the method, so we're going to go ahead and call, well, it doesn't have to be public, it can be private. Just private x equals whatever you want it to be, just 0, I guess. And that's just so that we can change that with the update method. And this is very temporary, we're not going to just be rendering ovals the whole time. But, yeah. And then the code we had in the while loop that changed x variable, we want to actually put that in the update method, although it's going to be a little different this time. We're just going to go ahead and increase x by an amount at the 60 frames per second rate. So let's just try 1 and see what happens. Plus equals 1. X. My bad. There we go. I worked too long in JavaScript now, so I forgot that you need identifiers. What? Yeah, int. Yeah, I just forgot the identifier. So this should run the same way it did before. I think the update method is being called for some reason. Let's see if they're doing something wrong down here. I'll just see on that monitor. Hold on. Okay. Let me just see if update method's being called. There's a very easy way to do this. Let's just go ahead and put a print line. I'm just going to debug this on here. Nope, so update's not being called for some reason. So let's figure out why.
Do you think that graphics like displays and buffer strategy is in
That's going to be in render now. That was in that root force loop that we had before. That's now going to be in the render. By the way, guys, I think the rest of these are just going to be recordings online on that website. And I actually think it will just be easier for everybody anyway, because you can pause it and go at your own rate. So, I think that's what we're going to do. So, what's this is telling me is that for some reason change in seconds is not getting greater than 60. So let's go ahead and do. Print out the change in seconds and just see what that is. Doing some live debugging. Alright, well, I think I know what the problem is. We're just going to go ahead and do what we did before, and I'll see if this changes anything. I think I actually misunderstood something there. Yep, okay. So what you want to do is, you do need the 60 frames per second up here, where we're doing the nanosecond conversion. So put the 60 frames per second up here. And then down here where you have change in seconds, make that greater than or equal to 1. And then what happens when I run this is the oval moves at kind of a steady rate, and it should move the same even on Vlad's really crappy laptop. Vlad's really crappy laptop is so slow it can't run the update method. What I changed is nanosecond conversion. I have it divided by 60, yeah. Change in seconds greater than or equal to 1. I switched those two. Yeah. Let me just go ahead and get rid of this now. We're not printing stuff. Print line is a very laggy thing to do when you're printing this often. This is what I'm getting. I think it's better than it was before. I think your computer is just really slow that it can't even run the update method at steady 60 frames per second. I bet okay, let's figure out how fast your computer runs. I'm going to set mine to 5. You set yours to 5, because this is just the frames per second right here. So now this is going to run now. Oops, this is going to run now at 5 frames per second. That's what 5 frames per second looks like. And as you notice, I changed it to 5 frames per second. That doesn't mean render is being rendered 5 frames per second. That means it's being updated 5 frames per second. 5 times per second, I should say. I shouldn't really use the word frames. So your computer can handle that speed, it looks like. That's pretty...
Really, it's still jumping.
I think that's a render, though, not the update that's causing that lag.
Like it's jumping.
I would try it on your computer at home. I'm sure it'd be a lot faster. And I'm going to change that back to 60, so we have our update running at 60 frames per second. So, I have some good news. Once I can get my mouse where I want it to be. We are done with kind of just setting up our project. We're really going to actually get into doing stuff with pixels on the screen. There we go. Just go ahead and start this new presentation. Okay. Let's get those pixels. So we're gonna get, what we want to do now is we want to actually get the pixels from our frame that we have, and we want to do things with those pixels, and then we want to put them on the screen again. And right now what we're doing is we're taking those pixels, even though we're not actually dealing with the pixels, and we're rendering an oval, and then we're putting it back. So we are doing that, we're just not actually messing with pixels. So there's a few more Java things I have to talk about first. And one of those is called a buffered image. And a buffered image is simply just an image of a buffer. And that just means that it's an image that is buffered into the code. It allows us to edit all of the pixels in the buffer for the image. And a buffered image is comprised of something called a color model, and then a raster of image data. And the color model is just kind of the red, green, and blue components, the RGB components, to actually render a complete image to the screen. And that's with all the colors mixed together to create some sort of color. And the raster is a rectangular array of pixels. So in other words, the raster is really all we're going to be dealing with. The color model is just kind of something Java deals with. And that's just going to be RGB or RGBA, which is alpha channel as well. But we're just going to we're dealing with RGB, which just means we have red, green, and blue and no alpha channel. And the data buffer that's in the raster, which is really the only part we're dealing with, stores all the pixel values in an array. So now we actually get to take the pixels, we get to put them all in an array, and then we get to change them. So we're really going to get into our own code now. We can soon be done with Java and then do our own thing. I mean the Java libraries, of course, but... and don't even worry about the sample model. So we also need to import... Actually, sorry. Let's go into the code and do this. So let's go back to our game here. Let's see, what can we... I want to figure out quickly what we can do before we leave. So what we're going to do, we're actually going to create a new class to deal with all of our rendering. Because right now we have quite a lot in just one class for game. And we really want to start to put things kind of in a hierarchy. That's not to say that we actually really have to do this. We just kind of are going to do this so we have kind of organization. And since this class is really just going to be dealing with rendering, I'm just going to call this class renderhandler.java. So create a new class in the same directory that you have game.java called renderhandler.java. I'm just going to open that now. So what we normally do when we're creating a class, it's just public class renderhandler. And then we also want a constructor for this class, because this class is not going to have a main method. Why is this class not going to have a main method? Well, yeah, but there's another reason. I guess that's the biggest reason, but the reason really is because we're not actually going to be running render handler as if it was its own application. Game is the application. Render handler is just, I'd like to say, kind of like a library that game is using. Yeah, it's just like it's pretty much gonna be the same thing as if game had methods for everything that was in render handler. It's just we're creating another class so we're a little bit more organized. Game's not going to extend any render handler at all because it's not going to actually extend the class at all. It's just going to create this class as if it was an object, as if it was an integer, anything, an object at all, and then call the methods in this class. Just like, we could just put them in game.java, but then it wouldn't be as organized. So the kind of thing we would do is if, this would be in game.java, so like in game.java, once we had created this, you don't have to type this, but we'd do stuff like, if this was an object, let's say render handler renderer equals new render handler. Don't type this, by the way, I'm just showing you what we're going to do. Then we can do renderer.render image, and then tell it where we want the image to be. If we want it to be zoomed at all or anything like that, and render handler will figure that out for us. We won't have to actually have all of that code in game.java. So does that make sense? So anyway, in our class here, let's go ahead and put in a constructor. Remember, a constructor is not, you don't put void, you just put a public and then the class name. I'm going to go ahead and make these brackets like you guys like them. Let's make it easy. See? Forgot about that. And I'm actually only going to have two parameters for render handler. And that's going to be the width and the height of the screen. So what we want to do in render handler is the stuff that we were talking about. We want it to get the screen as a buffered image. We want to be able to edit all of the pixels in the buffer. And we want to be able to do this with very simple methods like render image, render rectangle, render whatever. So that's simple enough. Let's go ahead and create our buffered image. Now this stuff is going to be very just Java based, so don't worry about it too much. Just import graphics first. We want java.auth.graphics. Java.auth.image, yeah?
You said that it's going to get the width and height of the screen?
Well, when we call this class, when we create a render handler object, we need to pass in what we want the width and height of our screen to be.
Sometimes when I play games and they start out in full screen, the game will start like an inch or two to the left of where it's supposed to be. Like there will be black space for like an inch or two on the right hand side of our screen, and then like an inch or two of the game on the left-hand side of the screen when you cut off.
That's a little bit more in depth. That's because of the aspect ratio of the game. That's not because of that's like the window and the graphics in that case were separate because they had the game with a very specific aspect ratio that if it just was put into any kind of monitor it had to be kind of changed depending on what the resolution was. So yeah, but we're not going to worry about that kind of stuff. All we're going to do is just say int width int height and create an image. So what I'm going to do is I'm going to create a few fields as well. And of course, once again, fields are variables within the class, not within the method. I'm going to create a buffered image, which we talked about before. It's going to be called view. Okay, and I'm just going to leave the actual initialization part or declaring part empty for now because we're going to be declaring this in the constructor. It's kind of like if I was just to set this equal to null, which is nothing, but it does that by default if I just leave it blank. Sorry. Another thing we want, remember I did say that what we're going to be getting is an array of pixels. And as it turns out, all of these pixels are integers. So all we're going to do is create an integer array and call that pixels. And also leave that undeclared up here because we're going to declare that in the constructor. So we have view and then we have pixels. And within our constructor here, the first thing we want to do is create, I'm just going to write a comment here, it's going to create a buffered image that will represent our view. So view, which is a variable, the field we had up here, we're going to set that equal to a new buffered image. And this constructor, we're never going to use it ever again except for right now. So I'm not even going to tell you what it is. Just copy it down. Well, what I can tell you is the color model I was teaching, or I was showing you, that is that right there. Passing in the color model and the width and the height of the buffered image. So I'm just going to let you copy that. Do you want me to make this bigger? Maybe I can make this bigger. Actually, I don't think they have font in here for some reason. Oh well, sorry. So yeah, don't worry about that too much. We're just creating a buffered image, which is an image with a buffer so we can access all of the pixels. And it has that height, or that width, that height, and that is the color model. And we're just grabbing that color model from a field that is in the buffered image class. And it's called type underscore int underscore RGB. All in caps. Go ahead and compile to make sure you don't have any errors. And if you're using Sublime Text, you can do Control B or Tools, and then build System, and then click Java C. Control B, and it'll actually compile it. And if there's any errors, it'll go down here. Okay, so next thing we want to do is the second field we have up there is just create an array for the pixels. And remember what I said was the array of pixels comes from the raster, which is inside the buffered image. So we want to do view dot get raster, the method is called. Once again, we're only going to use this once, so if you don't understand it, that is okay. I also don't know everything about the Java library, especially the graphics library, because it's a beast. Now here's the problem. For some odd reason, I never understand, the get data buffer returns it's called data buffer byte instead of data buffer int. So what we're going to do is we're going to cast this to something called a data buffer int. And honestly, if you don't understand this part, it's not going to be a big deal. And then the casted version of view.get raster.get data buffer parentheses around this whole thing. We want to do dot get data. And that actually gets the array, the pixel array of the screen. And that's a lot of random stuff, but what this has just done is this has given us a pixel array that we can change, and we don't even have to put it back into the data buffer. Because this is the actual, this is actually where the pixel array is. We've actually just created a, I guess, pointer, is what it's called, pointer to the data buffer array. So if we change anything in this pixels array, it automatically changes. So now that we've done that, go ahead and compile. I just did. And then we actually want to create another method. And this is going to be our render method. And all this is going to do is the same thing the render method was doing in game.java. And that is actually just render the pixels to the screen. And there's something simple that we can do here. What we want to do is the parameter for the render method is going to be the graphics that we had in the game. So go ahead and for the parameters, just call the graphics. So put graphics. Graphics is the type, and I'm calling it graphics lowercase g. And what we're going to do is, all we have to really worry about with graphics here is all we're going to do is draw our buffered image to the graphics. If I go into the Java doc for graphics, we'll actually go into that for this. Let's search for graphics. Graphics 2D, because that's more what we're doing. If we go to draw image, draw image method here, all this does is renders a buffered image that is filtered with whatever. All this does is pretty much renders a buffered image. And this buffered image OP filter, we don't have to worry about that at all. So I call that method by doing graphics, which is our lowercase g graphics, dot draw image. Then we want to put in what our buffered image is, which is view. And the next two parameters are the start x position and the start y position. And since this buffered image just represents the entire screen, where the start x and start y are just going to be 0, 0. That's the very top left of the screen. And the next two parameters is the end x and the end y. And that's just going to be view.getWidth and view.getHeight. Because we want this to go on to the complete view. So the start x and start y is 0, 0, the top left pixel, and the end x and end y is the bottom right, which is the width and height. And then the last parameter, I'm not even going to tell you what it is, just put null in, because it confuses me still. I'm not even going to tell you what it is, because that's the only thing we're going to do. So what we can do now, what we've just done is now, once we've called this in game, we don't have to worry. Hello, James. Okay. Well, what we can do now is not worry about Java graphics anymore. We have pixels. We can do things to the pixels. And just to prove that point to me, well, actually, first of all, let's go back to our game and actually create this, and I'll prove my point. So go ahead and and all we're going to do different in here is, first of all, the stuff that we currently had in the render method, we can just, well, here's what we can do. The set oval and set color thing, just comment that out. We still want everything in here. We want the paint graphics to paint the frame, and we want the dispose and the show. We also want the buffer strategy stuff up here. So just comment out the oval stuff. We don't want that anymore. And I think we had something to fill the entire screen so it was black. We don't really want that either. And all we want instead is we actually want to, in fact, let's get rid of this x variable as well and clear that out of the update method so we don't have random variables lying around. And now what we want to do is we want to create another field. I'm going to do this at the top because I like all of my fields to be at the top of my class, and that's kind of what most people like as well. So we're going to create a field for our render handler. So private render handler, and we're going to just call this field renderer. You can also call it render handler with a lowercase r, but I just like renderer. And now once we create our the very bottom of our constructor for our game, we want to create the renderer, because as you can see, I left it blank up here because we want to create it down here, now that we have our boundaries. And right now I think we just inputted the x and y via the code, because the x of this, as we can see, is 1000 from the setBounds method. The y, or I guess the width and height, this is the width, and this is the height. What we're going to do at the bottom of our game constructor here is we're going to actually create our renderer. So our renderer that we created up here with the field, I guess we declared or initialized, I can't, vocabulary. We didn't initialize, we declared, yes, we declared it up there, now we're initializing, yes. Renderer, we're initializing that to be a new render handler. And remember, we had two parameters, and that was the width and height. Well, what we can call, since this game is an extension of JFrame, JFrame has two things called getWidth and getHeight. Two methods called getWidth and getHeight. So just go ahead and call those, and those will be the width and height of the frame. And that compiled, so. The last thing we want to do is down back at our renderer method, renderer method, and we want to go ahead and, in fact, I'm just going to get rid of this. I'm not even going to comment it out. I'm just going to get rid of it. I'm going to go ahead and call our renderer.render. And remember, the renderer.render method, we had one parameter, and that was the graphics. And we actually have that right here. So we can just put in graphics. And it will pass that in, and it will render our pixels to the screen. Oh my gosh, this is going to be the most beautiful stopping point ever. I know why it is, because I'm about to prove my point, that's why. Did everybody get that? Everybody get that? Okay, cool. Down here, in the render method in render handler, now that we have all of the pixels on our screen, every one to them, just to test out stuff. So what I'm going to do is I'm just going to loop through all the pixels with a for loop. Remember how you loop through an array? Index for whatever our index is equal to 0. Index is less than. In fact, you know what? You write it. I'm not going to write it yet. I'll write the for loop. Then the stuff inside I'll let you mess with. So this is going to loop through every pixel in our array. Yeah? What we're doing is actually just doing less than. Yeah, we're not doing less than or equal to. If it was less than or equal to, then it'd go off the edge. But yeah, we're good with just less than. So I just do that by habit right now. I don't even think about it. So what you can do now is you can set pixels index to whatever you want it to be. So yeah, let's just put in a random number and see what happens. That was a very random number. Pixels. Oh, sorry. It needs to be int index. My bad. I mean, I normally don't do it. I've just been programming in JavaScript, and JavaScript doesn't have any identifiers other than var. But I mean, and that needs to be index plus plus. My bad. Yeah. So apparently that color that I chose was blue. I'm not really sure what it was, but yeah, it's blue. There we go. So what we have now is access to pixels that change randomly. And to prove my point even more that these pixels are changing, what I can do is actually create random pixels every single time this calls. Now don't even worry about this. This is hexadecimal, which you learned at the very beginning of the year, but you've probably forgotten, or have you, because we just haven't really done anything with it since then. Probably go back to it at some point though. I don't know. But yeah, this is just the math.random, which is a random number between 0 and 1, and I just typed in the biggest color you can have in hexadecimal. I think that's the equivalent of 16 million and something. Go ahead and compile. Oh, hold on. Oh, yeah, this is going to create a double, so we want to go ahead and cast this all to an int if you're doing this. You ready? Boom! And there you go. So that's randomly selecting out of the 60 million possible colors a pixel for every single pixel on the screen. And that is where we're ending today. So if you want to, between now and the next tutorial, or the next video that I'm going to be putting online, because these will all be videos now, which I think will be better anyway, because you can just go at your own pace. Mess with this, and
Those are indeed actual colors.
What?
Those are indeed colors, and not just gray.
Yeah, so the projector doesn't really show it well. You can see it on here though if you want. A little better. Oh, cool. What was that?
How often are you going to be doing these? How often are you going to be doing these?
He'll stay in class when the next one is, and I'll tell your class.
Okay.
Also, it's by using I. Okay. If you use I, you have to use I down there as well. Now run Java game. Well, you compiled render and that was the only thing you changed. But yeah, just go ahead and compile it now. And then run it. Did you call the render method? Actually, now think about it, it's probably working. It's just computer is. Yeah. If it's not enough tomorrow, you just maybe run that on your render. Oh no, you gotta put render.render graphics within this. You can copy that, put that up here before you dispose the graphics in there. That's why. So go ahead and read and see if that works. Sure. That was from a while ago. Yeah. So what's the error? I can't find that symbol.
It's below. And it is.
You want to actually create a thread here. Let's do thread for game thread. Okay. So thread is the identifier. So capital T, the thread, and then game thread with lowercase g is equal to new thread. And then pass in game, because what we did last time is you created a runnable, we made game a runnable, and threads take in a runnable. So, and threads, this was the entire last tutorial. Threads were threads are pretty much just executors of code. And we just created a thread so we had a little bit more control. Yeah, that changes every pixel every single time we call the render method. But what I just did. But you can do whatever you. Well, you could just not loop through all the pixels. I don't know. You can mess with that until next time. See what you can do.
Okay. Okay, so maybe we'll start. Is it getting into, you see your run? Okay, now render. Okay, do a print line there to see if it's actually even getting to there. Just like the system. What's the result?
No, I don't even know, because usually there's a few of them. I don't know, I'll just check over the recordings.
Okay. Yeah, there's probably just one line of code, a semicolon or something. That's usually what happens.